Okay, so let's look at how the graphs of a function and its inverse are related. Now, if you have a piece of graph paper, that would be preferred. I know not everybody has graph paper at home. So if you don't, just do your best at putting it in your notes. And let's look at the two functions that we had. Okay, so the original function right here, f of x is 2x minus 5. Okay, let me put that one in. I have f of x is 2x minus 5. Okay, that's just a line. There's my y-intercept at -5. So 1, 2, 3, 4, 5. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I usually like to put several points as opposed to just using my ruler. I notice if I only use a couple that my ruler can be off quite a bit sometimes. Okay, so there's that function. And then we said that its inverse function, f -1 of x, was 1/2 x plus 2.5. Okay, and you'll see that's why I changed that to 2.5, was just for graphing purposes. Okay, so here's 2.5, and then I'm going to go up 1 over 2. So up 1 over 2, up 1, over 2. I'm going to go down 1, back 2. So I have a lot of nice little points there. And then I'm going to draw that in. Okay. So it probably doesn't look like much. You're thinking, okay, how are those related? But once we put in the line y equals x, okay, this is a very important line. We use this line quite a bit in higher level math. And I want you to just think the y equals x line, that's a line that goes through the y-intercept at 0, right? Because it would be like plus 0 and has a slope of 1. So it just goes like at a perfect 45-degree angle is what I want you to think about. Okay, and anytime you hear about the y equals x line, this is another thing that I want you just to have an automatic in your head that you're thinking, oh, that's a line that goes right through the origin. It's at a 45-degree angle. Okay, so now, probably kind of hard to tell, but these lines are reflections of each other over this line. Okay, so this is the y equals x line. And I'm going to put down here that the graphs are reflections of each other over the line y equals x. And there's going to be a couple of ways that you can tell that they are reflections of each other. But basically, if we connected all of their points that go together, their points would make a line perpendicular to the line of reflection. Now, that's something kind of new. We have not talked about that before. But let's just see. This point right here, let's see, I've got -1, 2, 3, 4, 5. Okay, so it's 0 on the x, -5 on the y. Okay, well notice the inverse of that. Remember we said you would just switch x and y should be -5, 0. 1, 2, 3, 4, 5. Okay, it's not super accurate in my drawing, but it should be. Okay, so those 2 points are inverses. And look what happens if I connect them. So when I connect them, their line is perpendicular to this line of reflection. Now, that's going to be important because we're going to see that we're going to try to draw reflections over lines. And for those of us, I say us because I am the worst artist in the world, and I might not have done enough drawing for you guys yet to know that. but I have a really hard time visualizing things. People that are artists, when they see this idea and they say, oh, just reflect over that line, they just have this magic brain that says, oh, here it is. But let's just look. Let's look at this point right here. So this is the point 1, 1, 2, 3. So on the red line should be negative 3, 1. 1, 2, 3 should be right there. So negative 3. And if I connect those 2 points, that should be perpendicular. Okay, so notice it's perpendicular to the line of reflection. The other thing that's true when you connect these, and let me put another piece of tape down here, is that this little, see how that segment right there? The length of that segment is the same as the length of this segment. The length of this segment from here to here is the same as from here to here. Okay, so that's another kind of interesting rule. It's a geometry thing, but to know when things reflect that they are the exact same distance from the line of reflection and they are perpendicular to the line of reflection. Okay, so let's look at maybe graphing some inverses. Okay, so in your packet, page 15, I know we've skipped a bunch of pages here. Notice that it wants us to graph the inverse for each relation below and put your answer on the same graph. Okay, so you might have to pause the video while you go get that. But let's go ahead and put in the line of reflection. So I'm just going to put in the y equals x line here. Okay. Now, I am definitely not an artist. So one thing that I know I can do is I could go point by point. So let's see. So I'm going to say this black one is the original, the parabola, and this is the point 0, negative 1. Well, if I reflect that point, it should go to negative 1, 0. So that point reflects to right there. Okay, let's try this point. This is the point 2, 1, 2, 3. So that should reflect to the point 3, 2. So that point goes right there. Let's look at that point. So that point, if I look at this reflection, it's going to go right there. Okay? And then I can kind of see what's going to happen here. That it looks like it's going to go over something sort of like that. Now, we could go point by point. We could also get the equation. I'm going to show you how to cheat because I'm not an artist. Artist people, fasten your seatbelt because I know this is really weak. Okay, watch. I'm going to take the original function and I'm just going to trace it with my pencil. It's got to be a pencil. And I'm putting lots and lots of lead on that graph. Okay. Lots of lead. Okay, now I'm going to fold this graph right here the best I can along that y equals x line. Okay, and I might have to kind of look in the back. Okay, I have it folded on that line. And I don't know if you guys can see, but I can see through it, and I can kind of see where it was at. And I'm just going to draw on this page, and then I can see it right here. Okay, now if you're wondering, why did I just do that? Ta-da! Can you see it? So I can see that it's there and there. Okay, that doesn't look very good, does it? Okay, but that's the general idea, is that you know it's going to reflect over this line right here. And so if you're really desperate, you can kind of trace it that way. Now, art people, like I said, they're probably laughing at us and going, really? You really have to do that? Because they can kind of see it. They can go, well, that point right there would have to go there. Like I can kind of tell what it's going to look like, but see if you can get the inverses of these. Another way that we can do it is we can sketch we can get the equation and do it that way. Okay, I'm going to put this on the back burner because I just wanted you to see the basics on how to do that, and we can work with a lot more of those later on. But I just wanted you to get the main idea for now is that they just reflect over the line y equals x. Okay? And let's look at we're going to just focus today on getting the inverse. We're not going to graph them all. Okay. So let's say we're going to do another example. That I give you that f of x is equal to x squared plus 1. And I want you to find the inverse. Okay, so remember, our first step, we said put in y for f of x. Our second step, switch x and y. Our third step, solve for y. Okay, and I'm going to put y over on the left. Okay, here's where you have to be careful because we have a y squared. And we remember that whenever we go from a squared term down to a linear term, we have to put the plus or minus. So y is plus or minus the square root. And we would see that this is not a function. Because if, let me give you an example. If x were 4, or let's do this, if x was 5. If x was 5, 5 minus 1 is 4. The square root of 4 is 2. I would get plus or minus 2. I put in one value of x, and I got two values of y. Not a function. Okay, let's look at another one. Let's say we had f of x is x minus 3 over 5. Okay, first thing, I'm going to change that. Now, there's a couple of ways that you could do this, and it kind of just depends on what's easiest for you. Okay, I'm going to switch x and y. Now, I have to solve for y. I got to get this 5 out of there. So you could just think, it's divided by 5. The opposite of divide is multiply. When you multiply by a binomial, I want you guys to get in good habits here. Make sure you put parentheses. Okay, on this side, we don't need parentheses because that's a monomial. Okay, so this is just it's just having good habits. Okay, so I have that 5x is y minus 3. So 5x plus 3 is equal to y. And then I'm going to say, all right, y is 5x plus 3. Oops. And I forgot the very last step. We said to switch that to that. Okay, and I should have done that same thing over here. So I should have said f negative 1 of x is equal to plus or minus the square root of x minus 1. Okay, so that's all there is to finding an inverse.